Okay, let's start with our layout of our panels. And we need some way to work up at this roof level to lay these out. So what I'm going to do is I'm going to make a new layer. I'll go to the south elevation and we'll grab a layer, or excuse me, not a layer, a level. And I'll put it just a little bit below the roof plane there. And we'll rename that, PV panels. And what I'll do is I'll just, yes, we'll just hide some of this stuff so it's not so cluttery. Hide in view, sorry. Elements, oops. And get rid of these grids. Not really using them right now. Okay, so now we just have a clean outline of the roof, and we can start to think about what we can do with putting these panels side by side. And since they're laying flat, we can basically butt them next to each other. So let's just try to do that just to see what our maximum density is. And remember, we were making these 6 foot by 6 foot, so you know, I would think that would be the as tight as we would be able to get panels. Let's just move them off to the corner edge a minute and kind of check to see how much space we have between these two. 6 feet, so that works out nicely. So we're just going to move the whole assembly over 3 feet. So it'll be 3 feet from the edge. And let's move it up, let's just say at least a foot. And now we can go ahead and grab all of those and just copy them up. And I have it set on moldable, so we can quickly see what kind of density we can build. And we're probably pushing our luck with trying to ask ourselves to do that. We haven't even thought about roof drainage or anything else. So let me grab all of these panels again, and I'll move those down to the face of the building. And we'll take a dimension for our remainder here. 4'8", so we'll move it up 2 foot 4 inches. And let's take a little look at that from our 3D view again. And there we go, we have an array of panels. And if we select all in instance, I think it'll give us a count on those. So it says we have 80 panels, so that's 3, 6, 7, 8, and it must be 10. 3, 6, 9, 10. So we have 80 panels on our layout. So now we have an idea of how much area we have with real panels to do to generate power for our visitor center. And now I want to bring in the idea of using some math with this and spreadsheet development just to find out what our actual energy will be. So I've gone out and found a calculator. Let me move it on screen here. Just got to fiddle with it. Hold on a second. We can close this off now. I'll leave the data sheet there. But I want to bring this PV calculator to show you how this works. And it's not docking. Hold on a second. There we go. Okay, so I've already done one, and this is the idea here is it tells you how many kilowatts will come off of a panel system. And I'll go back to the beginning of this. If you were to come to this, let's go right to the general site. Okay, so this is how, if you go pvwatts.nrel.gov, this is the National Renewable Energy Laboratory. So they've gone, this is a reputable place to go to get your energy calculations. And I'm going to pick our site. I'll do Alfred, see if that comes up. Alfred, New York. And we'll go. And what do you know, it picks it out, no problem. And we'll go into the system now. And we want to know what the system size is in kilowatts. And what I want to do is I want to work with not the whole panel system, but actually just one module itself. So if we go out to our sheet, we'll look at what our output is in wattage. So we'll just pick one of these numbers. There seems to be a little variation in the models. So let's pick 330 watts. So let's look at what that looks like on this calculator. The DC system size is in kilowatts. And if I clicked on this, it'll give a little explanation of all of this, the size times each module times the module's efficiency. And so what we're going to do is, because we picked 330 kilowatts, it's only, or excuse me, 330 watts, it's only 0.33330 watts. It's a standard module, there's nothing special about it. It's fixed, which means that it doesn't track the sun, but it's a roof mount. And then this has the system losses. So we'll go to see what that looks like. And that's taking into all kinds of issues that might affect the performance of the collector in the real world applications. And we're going to start out with 0 degree tilt, which is not the optimum, but we are going to start with the azimuth degree at 180 degrees, which is directly south. If we open up this, directly south, 180 degrees. So our building is, we've aligned our building perfectly flat to meet with that. And then we'll pick we'll be using commercial power rates. And this is dollars per kilowatt hours. Very cheap, actually, it looks like here. But we're going to not really concern ourselves with overall cost. It's just a comparison of one system to another. So we'll go ahead and click to go to the results. And there's our output. So this is our total output per the year, and our monthly averages. So we have kilowatts per meter squared. I wish that was in foot squared per day, so we had a little easier calculation. And the amount of AC kilowatt hours kilowatts that come off of it in AC energy, and then what those mean in actual electricity produced. And we'll go ahead and we'll download the monthly results, so we'll be able to use those in a calculation. So I'm going to go ahead and download the monthly results, and we'll put that in the renewables one. It looks like I've already done this once, but I'm going to go PV watts, and instead of monthly, it's monthly, but I'm going to go PV watts flat panel. And I could say Alfred too. I'll just say flat Alfred. Now, I want to bring in this idea of the angle of and I'll bring in another web tab here, because we're going to run this calculation again. And I've already done it once, but I've gone to the site Solar Electricity Handbook, Solar Angle Calculator. I'll probably try to put a link on the website for you. But the idea here is that it gives you an optimum angle depending on a location. So I don't know if we can find Alfred. We can't. So we'll leave it at Buffalo. And the idea here is that in the wintertime, the angle very sharp, and that makes sense because the sun is low in the sky. In the summer, the angle is 70 degrees, because the sun is very high in the sky. The idea being that the sun rays being perpendicular to the surface of the panel will make it will produce the most amount of power. It's the most efficient when there's a 90-degree incident angle between the solar rays and the surface of the panel. So we can see right away that even putting a 30-degree angle on the panel is a more optimum setting. So instead of even concerning ourselves with the winter times, we may want to make a 70-degree angle. And when I say 70, we're actually just going to angle the panel by 30 degrees because we're working off of the tilt of the surface. And I hope that's the way it works. Let me see if that, in fact. So we'll go back. So we've already downloaded this data. I'm going to go back here again, and I want to look at this tilt in degrees. And so, and it's working off of a roof pitch. So at 1212, it's 45 degrees. So, and when it gets shallow, it gets to 18. So it is when they talk about the pitch, it's not as it's given in the calculator, which is off a vertical surface. It's off the horizontal surface. So the idea of using a 30-degree angle would be appropriate for our location. So I'm going to go close this off, and I'm going to change this tilt angle to 30 degrees and keep everything the same. And now I'm going to go to run that calculation again. And now we have actually better numbers. I don't have the other sheet right here, but we had this annual output that was at in the 3 range, and now it's up in the 4 range. So we'll go ahead and we'll download that because we're going to use that number in our charts when we lay these out in a Google Docs. So now I'm going to save that. I had PV watts flat Alfred, and now I'm going to have it PV watts, and we'll say, let's see if it'll let us put a number in there. PV watts 30 Alfred, and we'll save that. So when we come back, we'll look at starting to bring that data into a Google's Docs sheet or a spreadsheet so that we can start to do some analyzing.